Today we're going to do something that feels a little bit random. We're going to add and subtract some fractions with some algebra in it. This is for two reasons. First reason is this is the part of Algebra 2 that you did not have last year due to the stay-at-home order. So the Algebra 2 teachers did not go through this with you. And second part is because we're getting ready to graph these rational functions, so we're going to do a lot with them. And unfortunately, or fortunately, we do a lot with adding and subtracting fractions when we get to trig. So this is a skill that you will need to have. So we're going to just take a few minutes here to review over this. Let's just go back over just basically adding a fraction to another fraction. Let's say we have 4 over x plus 7 over x. They already have a common denominator, so you leave that denominator alone, and all you do is do the operation, whether it's adding or subtracting, you do that in the numerator. You leave the denominator alone. You don't add the x's together. You don't multiply the x's together. It's a common denominator. It stays common. It stays throughout the entire problem. So that's the first thing you need to do because the common denominator kind of drives the rest of the problem. A common denominator is a multiple of both the numbers and the highest power of any factor. So we want all factors. And if you have multiple choice, you want to pick, or multiple options, you want to pick the highest power. So for 4 and 5, like we couldn't pick 4 because you can't multiply 5 to get a 4. We couldn't pick 8 because 5 doesn't multiply to give you 8. So sometimes the best option is just to multiply them together. And then for the x's, we have a choice between x squared or x, and we have to go with the highest power. Now what I've done is I've already made the denominators match. That is the common denominator. So it used to be 4x squared. So essentially what we've already done is we've multiplied that by 5. That's how we became 20. So whatever you do to the bottom, you must also do to the top. So now we have to make the numerator catch up. So you got to multiply the top by 5. There's a plus sign there. The second fraction was a 5x. Well, we turned that into 20, so we multiplied by 4, and we multiplied by another x. So whatever we did on the bottom, we must now also do on the top. So 2 times 4x is 8x. So that's where we did this. So we found the common denominator, we fixed the numerator. Now to add and subtract, well, this one doesn't really do anything, so we're done with that. Step 4, reduce your final fraction. Well, in order to divide, we must be multiplying. So I'm going to take this down here. So in order to multiply, that means factor. So we're going to take out what they have in common. The numerator has a 2 in common, 15 plus 4x, and the denominator, of course, is a monomial, so it doesn't factor. But now we can actually divide. So it's 15 plus 4x over 10x squared. Do not worry about domain restrictions. We'll get to that once we get to the graphs. So again, the process. Start with the denominator. It controls the numerator. We need one of each factor. This x and this x are not the same. Let's say, let's assign it a value. Let's say x equals 2. So this would be 6 times 2, so which is 12, of course. This one would be 6 times 2 minus 2. This is 0. So they don't do the same thing. I know they're both the same letter, but they're not involved in the same operation. One's involved in multiplying, the other's subtracting. So clearly they both have an x. One factor is a plain, or 6 rather, one factor is a plain x, and the other factor is an x minus 2. So we actually have 3 pieces to the common denominator. This first denominator is missing an x, so we have to multiply the top by x. So that's going to be a 7x. Be very careful with subtracting. Very careful. There's a lot of tricks here. This one looks like it's missing an x minus 2. I'm going to rewrite this because this minus sign we want to keep track of. So we're going to multiply the top by x minus 2 because we've already multiplied the bottom. So let's fix this numerator. We have 7x minus all of this. When you multiply those two binomials together, x squared, you get a minus 2 and a plus 3. So that's a plus x. And then 3 times negative 2 is a negative 6. Denominator, still there. The last thing you do is try to cancel it top to bottom. Now we're going to have to distribute that negative sign. Denominator still there. Combine like terms. Negative x squared minus x. That's a 7x. I lost my x somewhere, sorry. So let's fix this. So x squared plus 6x, that's much better, plus 6. Now it is your responsibility to reduce it if necessary, which means you have to figure out if that's factorable. So let's try to change these signs around a little bit. It's easier to factor if we multiply by -1. Multiply to get 6, add to get 6. It's not going to happen. So it is not factorable. We do not have to worry about trying to divide that out. That is the answer. So here in number 3, we have one that has a common denominator already. All we have to do is go across the top and take care of these operations. So we have 8 plus 2x minus x plus 3. Be careful with subtracting. You will always change all the signs after that minus sign. So 8 plus 2x minus x minus 3 gives you, x plus 5 is still there. The top part is x plus 5. And they match completely, so the answer is just a 1. Now over here, we have 2 separate factors. So the common denominator will be one of each. 3x plus 5 times x plus 8. So the first problem, the first fraction rather, needs to be multiplied by x plus 8. And the second fraction needs to be multiplied by 3x plus 5. This is not cross-multiplying. We are not cross-multiplying. We are not getting rid of the fraction. It just feels like we're going diagonally because that's how the problem ended up matching up in this particular instance. So we have 4x squared times x plus 8. And then we have -10 times 3x plus 5. So let's distribute that numerator. We get 4x to the third plus 32x squared minus, don't forget that minus, 30x minus 50. Now that does factor, but it would factor right back to here. All right, if all we do is take out the, group it up, we would end up getting right back to where we started. So we know already that like these factors are not common, so it wouldn't really factor all the way. So essentially, it's not factorable. So we're not going to mess with it. This is the solution. Now in this one, the least common denominator is hidden because we have to factor this. 2 numbers that multiply give you 32, add up to give you 12. That would be 8 and 4, both negative. So we have a common denominator of one of each factor. The x minus 8 is right here, so we don't have to repeat it. So we have x minus 4 times x minus 8, just one of each. This guy is good. This whole fraction is fine, so we're not going to change that numerator. This needs to be multiplied by x minus 4. That's what's missing. So I'm going to rewrite this down here. So we have x squared plus x minus 3 plus 3x. I always do that. 3x times x minus 4. All over this. So we have x squared plus 3. Sorry. X squared plus x minus 3 plus, distribute, 3x squared minus 12x. Combining like terms, I'll put the denominator back on here in a second. We have 4x squared minus 11x minus 3. And the denominator is x minus 4 times x minus 8. So once again, we have to check to see if that numerator does in fact factor. I'm going to go with 4x and x because I want to get to a big number here. If I put the 3 outside, that gives me 12, and the 1 inside, I can get 11. But even despite the fact that it factors, it doesn't cancel, so this is the answer. So for those of you that would maybe forget to check if it's factorable, or don't want to check if it's factorable, you would get a little lucky there because it doesn't factor. Now for this one, you can see we have 3 completely different denominators. So we're going to have a big common denominator. We're going to need one of each. I'm going to put the x first, then we need x plus 1, and then we need 2x minus 3. So this first fraction, yikes, is missing a lot. It's missing an x and a 2x minus 3. So I'm going to rewrite this a little bit. So I'm going to multiply these two together just to keep this a little bit simpler. 4x squared times 2x minus 3. In the middle, this is really not here, it's just a 2x. In the middle, it's missing a plain x and the x plus 1. So x times x plus 1. So again, just to kind of simplify this a little bit first, I'm going to multiply these two things together. So this is a plus 2x squared times, of course, x plus 1. Then the third piece is missing a great deal. That third part is missing all of the factors. X plus 1, all of the, the bigger factors, 2x minus 3. I'm going to have to rewrite this a little bit. I'm going to distribute this. So we get 8x to the third minus 12x squared. Then distribute this, plus 2x squared, x to the third, plus 2x squared. Then finally, this last little part that I haven't written yet, we have a negative 4, and these two get multiplied together, which just in the interest of space, I'm going to multiply them up here. 2x squared minus 3x plus 2x minus 3. So this is a 2x squared minus x minus 3. All right, I'm going to leave the denominator off for just 1 second. Let's go back through this. 8x to the third minus 12x squared plus 2x to the third plus 2x squared. Now distribute the negative 4. The negative 8x squared plus 4x plus 12. Okay, here we go. X to the thirds, 10. X squared's a negative 12, a positive 2, and a negative 8. So that's a negative 20, so this will be a negative 18 x squared. The plain x's, just one, so plus 4x plus 12. The denominator, all of this, x times x plus 1 times 2x minus 3. Now this numerator, these first two have a 2x squared in common, leaves you with 5x minus 9. There's no way we're going to get 5x minus 9 in that second group, so it doesn't factor. The homework problems are, of course, on the back, so make sure you try those and bring all your questions to class.